Okay, so let's learn about Kafka. So we will start with a very basic tutorial of Kafka that should help you to know about the fundamentals in a very short time. So what is a Kafka? So Kafka is like a queue system. So why I call it a queue system, because basically it is a log system. So you just append the events in a file. So that is Kafka. Now of course Kafka provides you these functionalities in a very distributed manner, in a very scalable and reliable manner. So that's why the Kafka is useful. So if I'll assume that you guys know about the basics of a messaging system. So Kafka has a broker. So now this broker is installed on a server. So when I say server, it could be a physical server, it could be a virtual machine, it could be a container. And then here is the producer. So now producer is calling the broker and passing the events. And when it sends the events, it also tells a topic to which that event should be sent. Now what is a topic? So think of topic as a logical grouping of events. Now there are some details related to topic. We will cover them later. So right now think of it as a logical grouping of events. You can also think of these as a database table. So like how a database table has all the related rows which have the same structure in one table, right? So this is what a topic is. So let's say if you are sending all the events related to a customer, then you will say that send all these events to a topic called customer. Then so these so this is the topic, and then there are consumers which are polling for messages from Kafka, from this topic. So they subscribe to a topic. So that's why this is the pub part, this is the sub part, publish and subscribe. Now what we do is, so this is the default, this is a very simple naive implementation. Now another beautiful thing about Kafka is the persistence of messages. So since it's a log system, right, these messages are written on a disk, so it is persisted on disk. So now that means these messages are preserved for a time duration t. Now this t is defined by the customer, by the user, and it could be minutes, hours, days, years, anything which suits your need. So that means even after a consumer has read the message from a topic, that message will not be deleted. So that means somehow, let's say your consumers have screwed up, or maybe you want to add another consumer, you can always replay the messages very conveniently. And this is something which is not available in many of the other messaging platforms. And then another important, yeah, and then how these messages are replayed, or how the consumer tracks that a message, that what message it has read. So it uses a offset. So what consumers does is that it has an offset, that let's say it has read the 10 messages first, then it, when it goes to the broker, it says that I want to fetch more messages, and which are greater, where the offset is greater than 10, and then broker would provide more messages to consumer. And this offset is also stored on disk in a topic called offset topic. Okay, so now this is the rudimentary part of the topic and Kafka. Now let's see that life is not beautiful, right? It's always not beautiful. We know that things have to be scaled up, and so now what happens that was, so internally, if you see that this topic, this topic, now let me just write it again. So each topic has a partition by default, and it is hosted on one server or broker, you can call it. So what happens, so now again, and where it is actually stored, it is stored on the disk. So that means disk is a limited thing, right? So that means that when you have stored huge number of messages, disk could run out. Possible. Another second scenario, when there is only one partition, if only one partition, and you are writing at a high speed, one partition, that means one server, is not enough. And when such kind of things happen, if these kind of things happen in a database, usually what we do a beautiful thing called horizontal sharding. Right? That means your table has been broken down into smaller chunks, and then those smaller chunks can be stored on individual servers. So this kind of sharding is supported by Kafka, and when you want to do this, what do? You say that my topic, that means this is a numeric one, so my topic has to be partitioned. That means there have to be multiple partitions. Let me write it as partitions. So this is n, so that means there is a 1 to n mapping. So now what happens is that your topic is merely a logical, so this is merely a logical thing, and this is the actual physical thing. Now let's try to visualize it. Okay, so now when we say that it has been partitioned, it has been sharded, and you have multiple partitions and each partition runs on a separate server, that means you are going to have multiple servers. So congratulations, you have created a Kafka cluster now. So when you have a Kafka cluster, you have multiple brokers. So let's say let me draw it more cleanly. Right, so this is my server and a broker is running on this. And now let's say there is a partition. Let me draw it in some interesting color. Let's say green. Okay. So this is my one partition. And let's say these blue dots are the messages. Okay. And let's say that this is a topic called T1. This is the partition 1 of this topic. So that means this is the server 1. Now there has to be another server. Let me just duplicate it. Okay, so here is my server 2. And on this server, for the same topic, I'll have another partition 2. So this is the way we do the partitioning. And what partitioning does, it helps us to scale up, it helps us to increase the throughput. So here we are increasing the throughput, that how many messages can be written per second. So how do we increase that? And here we are scaling for the disk space. So yeah, now here is my good old producer. Producer. Now this producer has to write messages to these partitions. Okay. So how does it divide the message? So there are two strategies here. So let's say how producer decides that which partition should get the message. There are two approaches, and for understanding that, let's understand the anatomy of an event of a message. So let's say this is an event, and for this event there will be 4 things. One is metadata. So metadata headers, so these are similar to HTTP headers, you can say. Then there is a key, there is a value, and there is timestamp. was trying to draw a straight line. Okay, so this is how a message looks like. So you see there is a key here, but this key is optional. Okay, so now, and this key could be any unique ID in case you want to provide it, and you should provide it. Why, we will see. So how producer decides? So producer can play very dumb in case key is not present. So if key is not present, then producer is very dumb and it has to provide the messages, if send the messages in round robin. So that means message 1 goes to this guy, message 2 goes to this guy, message 3 goes to this guy, message 4 goes to this guy. This is your round robin. This is plain dumb. Right, now second approach is your consistent hashing. So first of all, concentrate on hashing. So whenever a message comes so whenever a producer says that I have to send a message, it will find out the hash of the message, and then it will do a mod operation on the size of partitions if there are n partitions, and by this it has found out that which partition this message should go to. And for this hash, it uses murmur hash, and it uses consistent hashing, so that even if these partitions can scale up or they can get reduced also, then also this hashing works fine. So to learn more about consistent hashing, you can Google it, or maybe if you want, I can create a small dedicated video for consistent hashing. It's a beautiful thing and you should know about it if you don't know about it. Right, so now we know about partition, we know about the how messages are passed to partition. Now let's learn a very important thing about partitions, and that is ordering guarantees. And this is something which is a game changer thing provided by Kafka. Ordering guarantees. I hope my spelling is correct. No, my guarantees spelling is not correct. Okay, so let's ignore it for now. So ordering guarantees. So ordering is guaranteed on a partition. And what do you mean by ordering guarantee? It simply means when a message is sent by a producer. So let's say it sends a message 1, then it sends a message 2, then it sends a message 10. So these are sent by producer to Kafka cluster, and now when consumer reads these messages, it is guaranteed that consumer will read it in the same sequence. So consumer will also see M1, then M2, then M3, and then M, and so on and so forth till M10. Right, these are the ordering guarantees. Now this ordering is guaranteed on only a partition. Right. So now why this is important? So sometimes people ask, they get confused that okay, that if there is a that I want to design something using Kafka, but I'm confused that should I have more topics or should I have more partitions, right? So in that case the answer is very simple, and that simple answer is that it depends. so let's learn about some ground rules which we can use. So number one, do you want ordering? Okay, so simple example is that you are trying to record all the events, all the messages related to a customer activity. So it could be that customer comes and he does login, then he browses some products, then he does add to cart, then he does checkout, and then he logs out. And now let's say you want to read these messages, a consumer wants to read these messages, and consumer is trying to make sense of the customer's behavior, customer's pattern on the website. Now you can say that these messages are logically different kind of things, right? Login is a different kind of entity from browse. Browse is completely different thing from a logout, right? So but if you put them on different topics, right? So let's say this is topic 1, this is topic 2. Now if you put them on different topics, that means they will reside on different partitions, and when they reside on different partitions, your ordering is screwed. Your consumer will not see this ordering. So that means one consumer the consumer could see the logout event first and the login event at the last, and consumer would be confused if you want to make sense of customers behavior, that how he is acting on the website, right? So in this case you would want to have a single topic, and that single topic would be customer, right? And if you create only one partition, then of course the ordering is guaranteed. The consumer will see login message first, then browse, and ultimately log out. But if your website is very busy and you have millions and billions of customers, so in that case you will create multiple partitions, right? So this is partition 1, partition 2, partition 3, and all these are different servers. This is server 1, this is server 2, this is server 3, and you can have any number of servers and partitions you want. And now let's say the messages come related to customer 1. So customer 1 says that my login has come, that customer 1 has generated login message. So login message goes here. Let me indicate it with a different color. Okay, so this is the login message for customer 1. Now the login message for customer 2 comes here, login message for customer 3 comes here. Now let's say login message for customer 4 comes here, right? So one customer so these are the customers. Now customer 1 has done a logout, so again that will go to this partition, right? So this logout message will be here. Now let's say if customer 2 has done a logout, so it will come here, right? So now you can see that the ordering is guaranteed. Now, what could be the other scenarios for choosing between the topics and partitions? So actually, you should not ask this question again. That do I want more topics or do I want more partitions? It's very very simple. That you start with a topic, and if you want to scale it up, then you add more partitions to it. So topic is the logical entity, and partitions are the actual physical entity. The valid question could be that I want a single topic or I want multiple topics. So that also we discussed that there could be some cases where where your login messages are completely different from logout messages. You want to treat them differently. In those cases, you can have a separate topic for login, you can have a separate topic for logout. But let's say you want to understand a customer's pattern. In that case, you want login, logout, and everything related to the same customer on one topic itself, so that ordering is maintained. Then second thing is that if you can also think that are your messages of same schema, right? So all the messages related to a customer should be on same topic, all the messages related to order should be on a different topic. But there could be an exception here also. Now let's say your consumer has to is doing some kind of analysis that and that it expects that for a customer related things and order related things are read by the same consumer. In that case, you may decide to have the same topic for these messages because the consumer is same.